Hi everybody, Rob Lawrence, METIS Product Manager for CGS ORIS Americas. Thank you for joining us in our second installment in our webinar series on digital decor surface innovation. Last week we started off our series with designing for digital decor with Peter Garlington of Interprint USA. And at that time I brought you into the front of our office so you could see where CGS was located. For today, our topic is scanning for digital decor. And I thought I'd bring us back to the warehouse, rather not the warehouse, excuse me, but our loading dock. Just because with scanning, oftentimes we're going to need to scan large originals such as stone or a door, or perhaps even hundreds of planks. So I wanted to see that we've got a large, fully capable loading dock for handling those types of things. So why don't we go inside and we'll get started with the webinar. Thank you. So we're coming into the back of CGS, into the METIS scanning area. And over my shoulder, you'll see our METIS DRS 2020, hard at work on a large, important scanning project. Before we get going into the webinar, I thought I'd show you a couple of examples of some projects that we have in the office. 6 panel boards, maple and oak, that are going to be used for a cabinet, digital cabinet printing project. Next to that is a barn door that we're using for another door project. And the 3 materials just below are an original that is our source material for 2 examples of unregistered textured digital printing. So without further ado, let's have a scanning for digital decor webinar. Thank you. Well, hi everybody. Thank you so much for joining us. I've turned my video off. I'm having a little bit of a lag in my video, so I don't want to lower or degrade any of the presentation material that I'll be showing you today. But we have a large number of people again on the call we're excited about, and so therefore we've muted everybody's lines. Just so as a matter of housekeeping, please use the Q&A feature. My colleague Emily Gustafson is a participant on this meeting as well, and we'll be monitoring those. And Emily, please feel free to interrupt me as a question might be raised during a part of a presentation. I'm happy to stop and answer it. We will do our best to address those questions, but if not, we can certainly respond at the end. And of course, we are recording this event and we'll be providing it to anyone that wishes to receive the PowerPoint presentation and or the video of today's session. So thank you for that. The business of producing decor surfaces for furniture, flooring, interior and exterior products is really a rapidly moving model. Here's 3 great examples of digitally manufactured product. We have an aluminum siding, we have an embossed and registered LVT product, and we have a natural low pressure laminate used in the furniture manufacturing process. We'll be sharing with you today the technology to create this level of realism. But a little bit about our company, for those of you that aren't familiar with us, CGS ORIS is our company. And we are a US company, and we are offering 3 main products to the market. CGS ORIS, a Germany-based color management software and proofing media company. METIS Scanners, excuse me, a Rome-based leader in surface imaging for cultural heritage and industrial markets. And AVA CAD/CAM, the UK-based industrial print and surface design software. This suite of solutions that we've put together are all really designed around the concept of objective tools to capture, to create, and then to communicate through an entire supply chain surface attributes such as color and texture and glossiness. Because what we see and touch and experience is always subjective, and you know the old saying, beauty is in the eye of the beholder. But at CGS, we're very passionate about objective data because we want to eliminate subjectivity and reduce rejects. We want to drive efficiency, improve speed to market, all while helping, at the end of the day, to manage our customer expectations from idea to finished product. So perhaps the phrase for us is, the beauty is in the data. This is important because in our manufacturing environment, We want our proofing devices and our prototyping machines. We want our sample partners and our manufacturing equipment all to reach the same desired effect, whether that's in one location or in a global supply chain. CGS's core expertise and technologies are really built on the concept that subjective elements like color and any other appearances, we can quantify these things, and we can use that objective data throughout the product life cycle to ensure a positive and repeatable outcome. Our first session with Peter Garlington from Interprint really talked about designing for digital and all the opportunities that are there. Today's session, we're going to demonstrate how we take those design ideas and take the color and appearances that we're trying to achieve, capture those, and objectively communicate them in a workflow. Our third in the series will be kind of discussing the rest of this workflow, so stay tuned for that. That's going to really be focused on using surface attributes for marketing, sampling, manufacturing, sampling, and marketing imagery. So stay tuned for that session. Okay, well, here we are. We are scanning for digital. So what do we have to do? We need to scan our original. So over the course of the next few minutes, we're going to walk through that process. We're going to walk through how we image it, how we optimize the data to meet the design and manufacturing goals. We're going to visualize our results. Then we're going to illustrate an example of how this data is used in a direct to substrate digital printing process. So we'll need to start with the imaging process. We do that because oftentimes our design inspiration comes from the natural world. It could be a piece of wood, a slab of stone, a series of planks, like you saw in our offices, a barn door, or it could be an original painting or a fabric or a textile. So if we have those and those exist in the natural world, we need to digitize and capture those elements. At CGS, we've chosen to partner with METIS. This is the Rome, Italy-based company, really because it's the capture method METIS utilizes is really driven towards objectivity. It's really quantifying things like color, things like glossiness, things like transparency, surface roughness. And when we can quantify those things, we can control them. And when we control them, we can repeat them. So this is why METIS is a key partner in this enterprise. METIS started in the 60s in the satellite imaging business, so sensors for satellites. Their technology was adapted for capturing and preserving our cultural past and is in the major museums, libraries, and archives around the world. In the past 10 to 15 years, these same technologies that are used to preserve our cultural past and to image, celestial bodies can now be applied to digital decor printing. So what we have in front of us is the basic, there's other scanners in the fleet for METIS, but for our application in digital decor, these are the primary scanners that you'd be using for these applications. And they range from small to large. Small for capturing textiles, small repeats, perhaps for the shoe or fabrics industry, wall covering industry. And then to the very largest where we're capturing very, very large and long planks or very, very heavy stone slabs. So moving on to our scanning. In this case, we're imaging, and we'll show a video of a wood plank being imaged on the METIS PM3D scanner. So the operator made a video here for me, and what we're looking at is the user interface between the scanner. You see on the left panel the controls. We'll be imaging this wood plank with 4 lights. The scanner is capable of imaging up to 8 lights for capturing things like transparency and glossiness. In this case, we're going to be capturing the attributes of color and surface texture. So we image this one, I think at 600 ppi, it said. Probably more than enough data for digital printing. Typically around 350 is going to be an ample resolution. But we crop our image and we ask the scanner to pass over this surface 4 times. So a quick video of the PM3D in Rome. passing over a wood plank. In this particular scanner setup, it can pass over the surface in an X coordinate and a Y coordinate as well. So it can get a full 360 degrees of lighting on the surface without having to move the object. As you can see simply, the sensor and the lights pass over the surface, and at each pass, they're gathering color, texture, and glossy attributes. So we'll wait a moment here as we see the light bar pass over. The METIS uses very powerful LED lights that are strictly temperature controlled. That lighting control allows us to keep the color uniform across the surface, and it allows us to do our calculations on the other attributes like glossiness and texture more accurately. A single scan captures everything you need. So what we're looking at in this slide are 4 typical outputs. The scanner is capable of many others, but in our digital printing application, we're interested in on the left, a diffused image. So an image that gives us a flat, if you will, color uniform image of that wood surface just as it is. A second image next to that is an image that has some shadow details that accentuates sort of the tactile essence of that piece of oak. So we can look and say that, that oak has some texture. The material to the right of that is a composite grayscale height map. That is a grayscale representation of the surface height exactly to scale. And the image to the far right is a 1-bit representation of that height map. Great examples of which files to use from a single scan. Some cases we are only going to print 2D, but we can print a 2D image with visual shadow details. That's a great application for our folks that are doing aluminum siding. They're not very close to this, the surface is generally maybe a meter or 2 away from the viewer. If they can have a visual influence of shadow, as you look at the surface, it appears very realistic. We don't need the actual texture. In our examples that we'll be showing later today, we are looking to either use a traditional printing process or what we'll be showing, a digital single pass process. In this application, we want to use a color file that has some shadow influence. So when we look at the surface, we see some shadow. But then we also accentuate that shadow detail with in-register wood grain texture. These 2 files will come together to give us a very low profile surface that's easy to clean, that gives us a real strong tactile visual appearance. So we can have a floor that looks natural, but one that isn't difficult to clean. That same application is used in low pressure laminates for furniture. So we would be using a printing tool along flat board, imaging with a color influence shadow file, applying a coating of that texture over the top. And again, the combination of the deep shadow and the slight tactile effect gives us a furniture surface that isn't too rough, but that gives us a natural appearance. Lastly, we're going to combine our diffused image with our grayscale height map. For this application, we might be engraving steel cylinders that are going to emboss a substrate. Or we might be producing on a digital multipass. In this case, we imprint the surface with 100% of the surface structure, and then we lay the color file over the top. The combination of the structure with the flat diffused image gives us a file that looks and feels like a natural wood product. Okay, so we've scanned the surface. The next step in the process is optimizing the scan data. I'll just pass along in my notes here real quickly. With the METIS products comes Light Inspector. Light Inspector is a tool where you can process the scanned data that we saw, so the raw scanned image that the PM3D captured, is now processed in the METIS software. And in this next video sequence, we'll be reviewing the process the operator goes through to inspect the surface for its color, and then importantly, inspecting the surface for its texture and its depth, and processing those files so that we can go on to produce a single pass, emboss and register digital flooring product. So in our light inspector software, the user interface is very similar to what you saw in the software that drives the scanner. In this case, on the right, we see our 4 lights, which are the 4 lights that we captured. And we're going to be using that information in order to inspect the surface. This is where the return on investment really becomes powerful with a technology like METIS is. The processes that you're going to see in the next really 3 minutes would have traditionally taking hours to days and required the use of tools that are frankly outdated and requiring a level of expertise that only years of experience in the industry can allow you to achieve these same effects. So we'll get started on the video and show you the power of this software.
Color. So what we also can do is...
So we're looking at the surface for color,
data,
but we're inspecting it for its structure. So in our software, we have the ability to virtually handle the surface. It's as if we have the original piece and we're holding it in our hand. But in this particular case, I can evaluate the surface. I can remove the color. So I only look at the 3D information.
Then I change a little bit here.
And I adjust, I'm adjusting some of the lighting features. Again, this is a 3D visualization tool that allows me to inspect the surface. So as I look at 100% of the file, I'm seeing that I've got a great depth of this image. It matches the sample exactly. But in the presets, I see that it doesn't quite capture the roughness that's on the original. So in my tools, I have a roughness tab, and I can bring out those finer wood grain details.
In a normal process,
the next step in the process is when I manufacture a flooring plank, I can't be, in this case, I don't want 1 full millimeter of pipe. I want to compress the information to something closer to maybe 3/10 of a millimeter or 300 microns. The software allows me to investigate the work that I had just done. I see that I haven't lost any details, and I'm able to save that file. My next step in the process is going to be converting that file to a 1-bit depth map. I need this 1-bit depth map in order to get my texture feature using a single pass digital process. So again, I go back to my tool where I can visualize the surface. I can inspect what the texture is doing to my surface. Right now, I'm going to look at the texture without the color, and I'm going to see that I have all the details of my 1-bit file. These are my in-register grains. And I'm going to amplify it to 100%. So as an operator, I'm looking at that file. I'm applying the color image to the texture image, and I'm seeing that the texture is in register with the grains that I'm seeing. However, as I move my lights around, I'm seeing that the texture is perhaps a little bit sharp, perhaps a little bit edgy, and maybe not that natural looking. So quite simply, with a matter of just smoothing the image out, just like we did to roughen up the surface earlier, I'm able to visually see the results of my corrections to the file in this window. And now I'm ready to send my files off to the next step in the production process. Emily, do we have any questions on the board so far?
Nope, none yet.
I don't think so.
I'm not seeing any questions yet, Rob.
For our next step in the process, we're going to take this information and we're going to be preparing our file for output. In the interest of time for today's session, we won't be going into a full demonstration of the AVA software to demonstrate all the features. We will do that on a separate webinar or certainly upon request. But we take our files from the METIS, we export the data that we're interested in. In this case, we're going to be exporting the color files as well as the texture data. And we're going to be using a software like AVA. Imagine it's similar to Photoshop, but in AVA we have tools to move knot holes, to align grains. There are algorithms specifically for the commonest materials that we use in our decor industry. So our first process is to take all of our individual scans and combine them into an all over or a template. In this case, it's a 4x8 panel. Next step in the process is to step and repeat that around, or rather, no, what we're first going to do is we're going to be eliminating our seams, removing some undesirable, I'll go back to the original, undesirable things like cracks in the wood, or perhaps too many knot holes, or perhaps too many visual clues that we don't want to see in this particular design. So with our template, we create a file that we think is pleasant. We want this to be our final product without seams. Because we're working with METIS generated data where the color and the texture is perfectly in register, all those changes that we've just made previously have also been made to the depth files and to the texture data. Again, saving countless hours of another operator duplicating those efforts. The next step in the process is now we step and repeat our 4x8 board around multiple times. And we look at the distribution of the color and we say, does that look good? Do we have too many patterns showing up, or does this look nice? We think this looks nice, so we move on. We go with this as our large 16 by 16 foot template of material. Again, same thing is true for the emboss and register data. None of that work has to be repeated. So we've built our design, we've built our templates, we're ready to go to the next step in the process. But before we do, we can take advantage of the METIS and we could take advantage of 3D visualization tools before we do anything in the way of printing proofs, prototypes, or certainly before manufacturing the product. So what we'd like to show you is how the METIS data can also be used in 3D visualization tools such as you see here. We show Blender, Kixel, Maya, V-Ray, very common ones in the industry. But all of the 3D visualization softwares take the same general type of data. And with this data, you can visualize your product in a different environment. In our case, we decided just to be fun and apply that wood flooring product to a wall, and you can see it on the right side of the screen on the post. And we can change our lighting conditions. So when we change our lighting conditions, the wood behaves differently. The reason it behaves differently is because the same files we're going to be using for manufacturing color, texture information, glossy information, these same files that we're going to be sending to our printers to ask to reproduce, we can also send those into CGI software. So here is a case study where a product, before it was manufactured, was visualized in a CGI BIM application for a large commercial project. With the METIS scanned data, we were able to provide color files, depth and normal map files, and glossiness data so that the client could visualize the product in their kitchens before ever choosing to manufacture any product. So the next step between 4 and 5 would be a paper and a physical proofing and prototype step. Please join us in our third session to go into details on how we can control the quality, the color, and the image communication in the physical proofing process. That'll be in our third session today. But for today, we're going to go right to a print production model. And in this case, we've had the opportunity to work with quite a few digital print manufacturers. And we'll be illustrating the Barbaron Jetmaster 1750 today. The process is quite simple. In our first example, we're going to be printing image onto a large sheet. And this can be a continuous feed of panels into the device, and it can be feeding different sections of our template into the panel at different rates. In our case, a large panel is going to go into the device. And ultimately, these boards are going to be cut out after the fact. And what we have with this process, by the pattern going through the press at different rates, and by our cutting out the boards out of that panel, we're able to have a randomized laminate board plank. This could also be for furniture parts, wood cabinet parts, more closely aligned to the processes that exist today. You can also emulate in this digital process. The second example that's possible today with digital printing is single pass digital direct to plank. Now think of that same model where we were imaging to a large wood surface and then cutting out the planks, but rather instead, we load the individual planks into the device. And as the device passes under the sensors and the print heads, it detects the area and prints only those boards that are directly underneath the print heads. And at the end of the process, we have randomized and registered planks ready for shipment. And at the end of the process, we have a digitally printed flooring material using our color and 1-bit information pulled off of the METIS to create these unique and one-of-a-kind digitally printed wood planks, the information that I showed at the start of our seminar. So I'm going to go back to video. Hi, everybody. And I wanted to see if we had any questions from the group. I'm looking on the chat feature and I'm looking at the Q&A feature. Well, participants, not too many questions. Ah, here we go. All right. So I have a couple of questions. How are you printing the embossed texture? In this case, the embossed texture is using a Barbaron technology called True Texture. This is where a coating is applied to the surface, and then a pattern is jetted onto the surface before that coating cures. So the pattern is applied via inkjet fluid onto a gelled surface, and then that surface is UV cured. Barbaron has the ability also to mechanically enhance that texture after the printing process by removing some of the looser material inside the texture. Hopefully that answers your question. You're welcome. The next question is, do you have any metrics to better understand scanning volumes that relates to an ROI for the scanner? You know, that's a great question, anonymous attendee. I don't have your name. There are a variety of metrics that go into the ROI, really in terms of testing your workflow currently, the time that the METIS scanner saves. We have metrics on the scanner speed at all kinds of different scanning modes. And then it becomes a matter of testing, for example, the workflow that I showed in converting those files into engravable ready data, and certainly data that can be used to use these digital inkjet processes. those times are very well known in the industry and are usually measured in hours to days for an operator to prepare those files. If you don't mind, I do have my contact information on the webinar, and I would love it if you could reach out to me directly. Go to my next slide. Yeah, go to my next slide. There's my contact details, and I can give you some more specifics depending on the area of your business that you're looking at. Thank you for the question. Is there anybody else? Okay, we have another question. Does this apply only to wood flooring, or are there other popular flooring surfaces you have experience with on these scanners? Yes, certainly there is vinyl flooring is certainly a great application for this technology. Ceramic tile, absolutely. METIS scanners, the ceramic tile industry sort of really was the first industry to pioneer digital, to get away from the traditional, really honestly, hand painting and glazing. They've advanced the digital printing process really from 10 years ago. They went all in. So I would say ceramic and stone, manufactured stone surfaces are areas where digital printing has really advanced, and absolutely where the METIS scanners are involved and are in fact in the ceramic industry in particular by far used by most of the companies in that industry. Again, if you want more further detail from me, I would really welcome a direct message to my email.